In the previous theorem, we have proved that root 2 is irrational number. Similarly, we can prove in a similar fashion, one can prove that root 3, root 5, root 7, etc., root p, where p is a prime number, are irrational numbers. Then, what about the numbers like 2 minus root 7 and 3 plus root 5, 3 into root 2 and 5 divided by root 3 or root 3 by 5 and root 2 by root 2, root 3, etc. How to prove these one? Now, we can prove that such numbers are irrational numbers by using the following fact, that is, rational number plus or minus irrational number, and second one, rational number into irrational number is equal to irrational number also. Third one, rational number divided by irrational number equal to irrational number, or irrational number divided by rational number is equal to irrational number. And lastly, irrational number divided by irrational number is also irrational number. The above numbers which I have mentioned, root 2 minus root 7, root 3 plus root 5, 3 into root 2 and 5 by root 3, or root 3 by 5 and root 2 by root 3, etc. They're all fall under one of the four cases here I have mentioned. Now we will prove, show that 2 minus root 5 is a rational number. Now the first one is a rational number and the second number, root 5, is a irrational number. And we know from the four facts which you have mentioned earlier, this is irrational number. 2 minus root 5 is a irrational number. But how to prove it? Now, the irrationality of 2 minus root 5, I am going to show this is an irrational number. And now, if possible, assume that. Assume that two minus root 5 is rational. Then 2 minus root 5 is equal to a by b, where a and b do not have a common factor, where a and b do not have a common factor, or we can say they are relatively prime to each other, common factor. Now, we can see here, this implies root 5 is equal to 2 minus a by b. By taking minus root 5 to the left side, right side, and a by b to the left side, that is 2 minus a by b. That is going to be 2b minus a by b, which I can write down c by b, because 2b, where c is equal to 2b minus a. 2b minus a is also an integer, and so let me write down that c is equal to 2p minus a, and therefore that is equal to c by b, and which is irrational. This implies that root 5 is rational. Because c by b is a rational number. Now you know square root of any prime number is also always irrational number, a contradiction. To the fact that root 5 is irrational. And hence, therefore, 2 minus root 5 is irrational. Next example I would like to consider here, show that 5 into root 2 is irrational, and the solution is similar to the above, that if possible assume that assume that 5 root 2 is rational, and that is 5 root 2 is equal to a by b. That implies root 2 equal to a by b into 1 by 5, that is a by 5b, and that is a by c, where c is equal to 5b, and therefore it is therefore root 2 is rational. Again, a contradiction. Because why it is a contradiction? We have already proved that root 2 is irrational number. Therefore, it is a contradiction. Therefore, 5 root 2 is irrational.